I'm here to give my perspective on healthy longevity, as a scientist and as a geroscientist. But before I do that, I'd just like to say that as someone who's admired the work of the UCSD Center for Healthy Aging and the Stein Institute for many years, it's really been an honor and a highlight of my career to have been able to help drive the research program for the past year and a half. I'm deeply grateful for my colleagues and also our team of very dedicated scientists who all share a passion for research and a passion for promoting healthy aging. So as I hope you're all going to recognize today, we've been really working hard to ensure that we continue that legacy of excellence in research while also expanding to new areas and new directions that will help to ensure that we remain at the forefront of aging research for years to come. So with that, I'd like to start the same way I start in many of my lectures, which is by sharing with you our goal as aging researchers. So one of the ways I can use to describe this goal is by showing you a lifespan curve for a given population. So in this graph, what we have is the health of the population on the y-axis and the age of the population on the x-axis. So I think we all recognize that overall health of a population does decrease with advancing age. And when that health goes down to zero, when it drops down to zero, that represents the lifespan of this particular population. So I'm sure many of you are aware of research efforts to try to extend the human lifespan. Anyone aware of those efforts? And that may even be why you're here today. Well, accomplishing that goal would lead to a shift in the curve that's represented by this dashed red line. But now, coming from a more clinical perspective, a central goal of our research is better depicted actually by this green line, which represents an extension of health span. So in this curve, the overall health of the population is maintained across all ages without necessarily extending the lifespan. However, breakthroughs in aging research are now informing us that many of the same underlying mechanisms that drive age-related diseases and conditions are also involved in the processes of aging itself. So this recognition by the scientific research community makes it plausible that maybe one day we can come up with a strategy for extending both health span and lifespan, and that's depicted by this purple line. So to me as a scientist, this is what to me represents what we do in healthy longevity research. So as you can see, now is really an exciting time to be engaged in aging research, not just as scientists, but as members of our community, particularly here in San Diego. So I'm going to return to these concepts again in a little bit, but first I'd like to ask you, the audience, what you think the current human lifespan is. So by a show of hands, who thinks that the current human lifespan is 85 years? I see a couple, so that's actually around the average. How about the maximal human lifespan of 100 years? A few more hands, maybe 120 years? Well, actually, if we take a traditional definition for the lifespan, maximal lifespan of a species, that is defined by the oldest age achieved by an individual of that species. So for us as humans, that's actually 122 years and 164 days. And that record was set by Jean-Louis Calment from France. Now for men, what do you think that number is? Well, it's a little bit lower. It's 116 years, and that record was set by Jurman Kimura from Kyoto, Japan. So amazing examples of exceptional longevity live among us. And as someone who's been doing aging research for over a decade now, I've had the pleasure of meeting people who truly exemplify our goals for healthy longevity. Now, I also like to think that as a society, we're beginning to recognize that aging is beautiful. All right, who agrees with me? Great. Because for those of you who don't believe me, let me tell you about APO Wang OD, who just a few months ago became the oldest person to ever grace the cover of Vogue magazine at 106 years old. So in my home country of the Philippines, Wang OD, who lives in the Cordillera mountain region, is considered to be a national treasure. So she's a traditional tattoo artist, And she practices something called Mamba Batok Kalinga tattooing. And this is a type of tattooing where those patterns, like you see embedded into her skin, are made by repeatedly tapping a long, sharp thorn that's been dipped in a homemade ink with a stick. And you can see her doing that in one of those pictures. Now, this practice requires a lot of precision, and it's a tradition that Wang OD continues to keep alive and pass on. So we all love to learn about centenarians and even supercentenarians. Those are people who live to over 110, because they teach us about what is possible. So unfortunately, at present, as a population, we're still far from achieving the potential of our species. So the challenge for us as aging researchers and as a society is to figure out how to unlock that human potential. So I really like this image because it shows the unlocking of a single puzzle piece. This highlights that there's not likely a single lock that we need to open, but rather a number of locks that, if we're able to open, can get us incrementally closer and closer to our goal. And indeed, we know that there are multiple factors that contribute to healthy longevity. I'm sure you're familiar with these factors, things like genetics, nutrition, environment, and lifestyle. So let me talk a little bit about genetics. Well, a lot of what we know about the role of genetics actually comes from our study of centenarians and people who live in blue zones. I'm sure many of you are familiar with blue zones. Well, it turns out that centenarians have protective genes that seem to delay aging and protect against age-related diseases and conditions. However, what's really important to me is that research also shows that these genes account for less than 1/3 of your chance to living to the age of 85. So to me, this represents an opportunity. And it means that we can focus our research and research that we do at the Stein Institute on these other factors that we can actually do something about: nutrition, environment, and lifestyle. So over the years, the Institute has made major contributions to our understanding of the roles of diet, exercise, our microbiome, activity patterns, and social connections in healthy longevity. So the same way that multiple factors contribute to healthy longevity, well, healthy longevity itself is comprised of multiple domains. So these domains include physical function, cognitive function, sensory function, and also mental well-being. So all of these contribute to functional independence and quality of life as we age. So in the research that's being conducted in our own laboratory, we deploy a battery of tests that inform on healthy aging across all of these domains. So if you volunteered for one of our studies, or maybe you're planning to in the future, these are just some of the tests that we deploy and you may be asked to perform. So these include cognitive tests on things like an iPad, sensory tests, and also tests of your physical ability and physical fitness. So these are actually images of our team, myself included, rigorously testing out these assessments to ensure that we have a rigorous data collection, and importantly, the safety and acceptability of all of these different measures that we do. So much of the research being conducted by my laboratory is driven by the principles of geroscience. So this field was born from the recognition that aging is still the single strongest risk factor for major chronic diseases and functional decline. Therefore, as geroscientists, we're working to understand the genetic, molecular, and cellular mechanisms that make aging the driver of common chronic diseases that older people experience. But what's important are the implications of this hypothesis. And I think these implications are quite important for healthcare, and in particular, geriatric medicine. So traditionally, the practice of medicine has been focused on treating specific diseases, as shown here. So intervening only after you see the symptoms. More and more, there's a growing focus on prevention, particularly in geriatrics, as shown here. But imagine if we could intervene and slow the aging process itself. So the implication of this is that we can have a therapy or a way to prevent multiple age-related conditions using a singular strategy. So what's exciting is that our field has actually identified a number of cellular processes that drive aging, and these may all serve as targets for the development of such gerotherapeutics. So in my own lab, we focus on mitochondrial dysfunction. So these organelles are what are responsible for providing your cells with the chemical energy they need to do their function. Mitochondrial function does decline with age, and our work and the work of others has linked this decline to dementia, frailty, heart failure, and other conditions of aging. But what's promising is that we've observed that mitochondrial function is malleable. This can be improved by various interventions and behaviors as well. So suggesting that this organelle, which we've been studying for over a decade now, may be targeted to improve healthy longevity. As part of my opening remarks for today's Healthy Longevity Symposium, I'd also like to take some time to introduce you to some of the programs, resources, and initiatives that are supported by our center and the Stein Institute. And these are really meant to broadly support efforts to better understand, among other things, the drivers of successful aging, understanding aging itself, understanding how to deliver successful interventions, and understanding resilience, which I'll talk a little bit more about in a second. So the first of these, which has been mentioned already, is the Successful Aging Evaluation, or the SAGE study, which was initiated years before I even joined UC San Diego. So this is what's called a prospective cohort study, and it's comprised of randomly selected and representative community-dwelling residents of San Diego County. So there were two waves of enrollment that occurred, one focused on older adults and one focused on younger adults. And there's been yearly data collection since then. We actually just completed our 2023 data collection, or inputting the data now. So the SAGE study has really been central to not only the research we're doing in our center, but the training that we're providing as well. And a lot of seminal findings about wisdom, loneliness, and mental health have actually come from this study. Now, I see a lot of new opportunities for the SAGE study. So I think there's opportunities to study exceptional longevity. As you can imagine, we have a lot of nonagenarians in this cohort now. We also have an opportunity now to look at the impacts of COVID-19 on healthy aging. So this is something we're looking at. And also, we're interested in expanding the diversity of this cohort, acknowledging that San Diego is a diverse place. So we're focusing in on communities that have been historically underrepresented in research. So these are the things that we're really looking forward to doing in the upcoming year. You've also heard a little bit about our Living Lab and its recent launch. So this was really made possible by a partnership with Belmont Village and its residents. And this is a lab that's actually embedded within the community in a Belmont Village building shown here that's located close to our medical center just off the 5 freeway. And what's exciting about this is here we have a really unique opportunity to partner with older adults, not just in doing our research, but also in the conceptualization and the design of our research. So I anticipate that a lot of our most important research ideas and directions are going to be coming from you and coming from people working with us through this facility. We're also playing a central role in efforts to understand the biological basis of aging itself. So the San Diego Nathan Schock Center for Excellence in the Basic Biology of Aging was launched in 2020 with support from the National Institute on Aging and is led by Dr. Jerry Shadle at the Salk Institute in partnership with us at UCSD and folks at the Sanford Burnham Prebys. So our team at UCSD has been responsible for the ongoing enrollment of a new cohort that's representative of the adult human lifespan. And what's exciting is that we have a multi-domain focus again on healthy longevity and health span. So we're measuring all the things that we're interested in: physical function, cognitive function, sensory function, mental health. And from these individuals, we're deriving new innovative cell models of aging. And these are going to be a valuable resource for efforts to understand the cellular basis of aging itself, and also for potential drug development. So we're really delighted to be part of this. We are involved in a new international effort to promote healthy aging that's supported by Wellcome Leap. So Wellcome Leap is a unique funding organization because they aim to deliver breakthroughs that could fundamentally change science and transform human health. And in their own words, they seek to build bold, unconventional projects. So the goal here is to achieve breakthroughs that can impact and provide solutions within 5 to 10 years. I really like their logo because it shows how Welcome Leap is taking approaches that led to major scientific breakthroughs in areas such as space exploration, but now applying them to human health. So what are we doing? Well, first of all, this is an international goal. The program is called Dynamic Resilience, and it was jointly funded by Welcome Leap and Temasek Trust. And what's exciting is that we are going to be part of this international program, and in the upcoming years, working with an international team of experts representing academia and industry, discovering new ways to improve resilience and to unlock our potential for healthy longevity. Let me talk a little bit more about resilience, at least from my perspective as a scientist. So not too long ago, healthy aging was characterized by your ability to avoid disease. But more recently, it's been recognized that equally important to healthy aging is the ability to bounce back after physiological stress, right? So our goal for this program is to uncover the drivers of the resilience and apply them in real-world clinical settings that impact the lives of older adults. So how are we going to apply this? Well, falls and injuries that they can lead to remain a major concern in the lives of older adults. So fall-related injuries are the primary cause for loss of independence. They lead to things like hip fractures, traumatic brain injuries, and 25% of people over 65 experience falls. 1 out of 5 of these falls results in a serious injury, and over 3 million emergency room visits per year. Now, what's really concerning is that older adults who fall are twice as likely to fall again. And this can lead to cycles of hospitalization, rehospitalization, and accelerating decline. So what we want to do is understand why some people bounce back and why some people don't, because that's the first step to being able to do something about it. So the great thing about working at UCSD is, we have excellent patient care and world-class research all happening under the same umbrella. So we really had an opportunity to bring together an exceptional multidisciplinary team to tackle these big healthcare issues such as falls. So we're partnering with California's first gold medal accredited geriatrics emergency department and scientists across our campus to better understand why falls happen and why some people bounce back and some people don't. So I'm really honored to be working with this, what I consider to be a dream team of scientists and physicians. We believe that by understanding the different types of resilience, something that we're calling dynamic resilience that happens with things like falls, or lifelong resilience, which is defined by your ability to maintain functional capacity over time, we're going to be able to get a better sense of drivers of what we're calling universal resilience. So a key point of this work is that the drivers of universal resilience are going to be comprised of those shared molecular and biological features between lifelong and dynamic resilience. So what would be the potential impacts of this work? So even beyond falls, I think this is one of the keys to helping to unlock and advance precision medicine for older adults, because understanding universal resilience is going to help us understand how one recovers from infection, how people recover and benefit from surgery, and also, predicting the progression of age-related diseases and conditions. So again, resilience playing such a key part in all of these things related to healthy aging. Okay, so that's my time for today, but I cannot finish my presentation without sharing the most important slide. These are the individuals who actually make everything I've shared with you today possible. This includes researchers, fellows, students, and these are people who are all invested in really improving the experience of aging. So with that, thank you. Thank you for your interest. Thank you for your support.